Hello there, welcome to the Grade 9 Advanced End of Term 3 explanation videos. I'll explain all the 23 exam topics in these coming videos. Do watch them in continuity, watch the first video and then the second and then so on. But if you already know the topics thoroughly, yes, you can jump and it's easy to navigate because each video is named based on the topic. So please use this videos to the fullest. I'm Justin D'Souza, your math teacher, and this is my channel. If you have not yet subscribed to it, please do hit the subscribe button. Subscribing is free, but it would mean a lot to me. And I want to thank all those who have subscribed. I really and greatly appreciate it. Thank you, guys. Now we will begin. But before we start with the explanation videos for the first topic, I will quickly run through the Heikel, that is the exam scheme. Here you have three parts, that is part 1, 2 and 3, where the part 1 and 2 is 10 topics each, whereas part 3 is the writing. Only 3 questions will be asked. But the marks differ. The part 1, 10 questions will have 3 marks, whereas the part 2 has 5 marks each. And the writing varies from 6 to 7. The 2 bonus questions are also in writing, that is in part 3, and they are 5 marks each. The part 1 is supposed to be much easier or simpler compared to the part 3. We will do all the videos, so not to worry. And the part 2 over here, 11 to 20, and then the last part. Please do revise thoroughly. I may not be able to solve each and every problem. I will give you an idea how to solve that specific objective. Say, for example, this topic, I will solve 1 or 2 problems. But it is up to you to solve more problems. The more problems you solve by yourself and practice by yourself, you will be more thorough. So please make an attempt to solve it, write and solve. It is very crucial. And I wish you all the very best and happy learning. The first topic is to write and analyze conjectures by inductive reasoning. Basically, we need to analyze some patterns, or you need to predict what's going on, in set of values or set of times, or in this example, we have appointment times. Let's see this. Write a conjecture that describes the pattern in the sequence, then use the conjecture to find the next terms in the sequence. Conjecture is telling something, it's not like a conclusion, but it's similar to a conclusion. You're saying this is what's happening. Now you can see the appointment times, that is 8:30 a.m., 9:15 a.m., 10 a.m., 10:45 a.m. So what's going on? It might be a doctor's clinic, and the appointment times are given such that after every certain time you get another appointment. So if you look closely, analyze this, look for the patterns. Now, what's being done? Over here, you can see there's 45 minutes gap from 8:30 to 9:15. Again, 45 minutes. Again, there is a 45 minutes. So what will be the next appointment time? Add 45 minutes to 10:45. That will be 11:30. So this, each appointment is 45 minutes after the previous appointment. So the next appointment will be 45 minutes after 10:45 a.m. That is 11:30 a.m. or 11:30. So this is how so simple this is. Now let's see another problem where there are numbers. You can see there's number half. Then 1, 2, 4. What would be the next number? Again, write them and analyze the pattern over here. It's 0.5, 1, 2, 4. If you can see, you're multiplying by 2, isn't it? Over here also it's multiplied by 2. Again, it's multiplied by 2. It should be good for all the terms. It should be the same pattern for all the terms. And now you know the next one will be again multiplying by 2. It's multiplied by 2. So all you need to do is multiply 2 to 4. And you will get 8. The 8 is the correct answer. This is it. So now these problems are for you to find out. Take your time, try solving each of them, and then compare the answers. So over here you can see 4, 8, 12, 16, 20, it will be 24 and so on, because 4 more than the previous term. Here you can see it's 2, 2, 2, 3 2s, 4 twos, 5 twos, and so on. Same way over here, multiplying half each time, and it'll be multiply 2 in the denominator or half to the entire term. Over here, now this is interesting. Here you're just doing each term 1.5. Okay, sorry. If you analyze this properly, now you can see 1 is being deducted, and this is what? 11 by 2. This is 5.5, 4.5, 3.5. So basically half is being deducted. Okay, so over here, just that it's not written in the decimal places, so that's why you just get confused. But if you look carefully, it is 6. 11 by 2 is 6.5, 5.5. So then it is 5. Then 9 by 2 is 4.5. And then we have 4. And then next one will be 3.5. That is 7 by 2. So that's the answer. Same way over here, we did a times problem. Similarly, you can find the times. And over here, percentage humidity is reduced by, here it is 7. Over here, 7. So next one will be 79%. So that's the first step. Over here again, you can see there is some pattern over here. 3, 3, it's keep on moving. So it is being shaded over here now. What's happened over here, over here, over here, over here? Now, this, and next one would be going up. Why? It's on the counterclockwise. And then this pattern is reducing over here. And the next one will be just 2, because from 4 it's reduced to 3, then it's 2, and it's 1, similarly. And then now we will look into last type of problem. It's still in the first topic. There's one question. See, the question number 9 is included. That's a different type. Now, say, for example, they are asking you, make a conjecture about the sum of squares of 2 consecutive natural numbers. List or draw some examples that support your conjecture. Now, they're asking you to make, find sum of squares of 2 consecutive natural numbers. What does it mean? Natural numbers are counting numbers. They are like 1, 2, 3, 4, 5, 6, all those, okay? 0 is not included in natural number, and it's only whole numbers like 1, 2, 3, 4, and so on. Now, 2 consecutive means if I choose 2, then the next one must be continuous. It will be 3, and then it goes on. We need to sum the squares. That means we need to square this plus square this. So think of any number in your mind and write it down. I'm thinking of 7. Okay, square this plus the next term, 8 square. Okay, we need to find the pattern of that. So let's take some examples over here, random examples. 1 square plus 2 square, 7 square plus 8 square, 10 square plus 11 square. Find the answers. You can find more, but these are plenty of examples over here. What is it? Does it end only with 1? No, 3, 5. But if you look closely, you will come to know that all these numbers will end only with odd numbers. See, all the sums are odd numbers. So the conjecture is the sum of squares of 2 consecutive natural numbers is odd numbers. That's it. Similarly over here, the product of 2 odd numbers. You need to take some examples. Take 2 examples over here, and then, wait, sorry, over here, let me take. Now, what do you take is the product of 2 odd numbers. Let's take any 2 odd numbers, 3 into 1, or 3 into 7. You can take huge numbers as well, but it's just that you have to calculate it by yourself. So take reasonable values. It doesn't need to be consecutive, so it's fine. Okay, let me take 5 into 7, or say 7 into 7. Okay, you can take more examples. Multiply them. Over here, the answer is 3. Here it's 21, 35, 49. Every time 9 into 3, 9 threes are, it'll be 27. So every time you take 2 odd numbers, the product is also an odd number. That is the conjecture. You take some examples, check it out, and then you can write it. So these are the 2 types of questions. So if you're getting confused, just go back over here. Everything is mentioned in details. You can follow the same steps and try. You can try some more, You can try more examples. Say, try the product of two even numbers. Sometimes they you might not find any relation. That is fine, but sometimes you do find relation. You can try, perfect squares, or squaring, add the squares. Try different things, odd squares. Keep trying. You can find the patterns. So this is it. So see what is given and then find some examples and then give your conjecture. The second topic is to prove theorems about angles. We're dealing with angles. Mainly we have to use this angle addition postulate. It is very basic, very simple. Only few concepts needs to be remembered. Now, whenever you see this 90 degree, what does this mean? That is 90 degrees. Sorry, I told whenever you see this 90 degree, this is a right angle. Sorry, whenever you see a right angle, you must remember it is 90 degrees. That is the first thing. And also you must always remember, if there are many angles formed in a say over here, you can see there is one angle, one angle, one angle. Many angles are formed in this figure. The sum, if it is known, must be equal to sum of the individual angles. What it means is, now if you add this 1, 2, 3, it must be equal to the total sum. So how do we find it? If this total is given, now let's solve this anyways. They want to find this the third one. They have given you the first and the total. You know the second is 90. All you need to do is the total minus 1 and 2 will give you the 3. Let us see over here. First analyze the given figure. We know what is given in the figure, sorry. 1 is given, 2 is not given, but you must know 2 is 90 degrees. And then total angle is, that is measure of ABC, that is 131. Now what do? Apply the angle addition postulate. What it says is, if you add 1, 2 and 3, the total sum must be equal to the 131. And then what you do is just simplify and solve. This is by substitution property, where we substitute all that we know and find the unknown. So 131 minus 23 minus 90 will give you 18. And that is it. That is the answer. Similarly, using this concept, the little complicated problems can be solved, whereas over here there is no angle, there is no 30 degree, there's no 40 degree, it's just in x and y terms. But it's the same. Over here they have told measure of angle 4 and measure of angle 5. Now which is the theorem that you know over here? See, a straight line is always 180 degrees. So now if it's a straight line, it's always 180 degrees. If it's a circle, it is 360. If it's two sides, a protractor, for example, you have 180, 180. So total will be 360. But if it's only one, then it is just 180. Now this straight line can be tilted. It can be tilted like this or like this. Anywhere you will have 180 degree. So now, for example, over here, 4 and 5, measure of 4 and 5. Here, 4 and 5, if you add it up, it must be equal to 180. There is no other angle. So it must be equal to 180. So add. And one more thing, if this is 4 vertically opposite angles, so they are also equal. 4 and 4 this will be, and this will be equal to over here, it will be 5. So this is one more thing. But for now, this 4 and 5 will be equal to 180 degrees. So some of these both will be 180, right? So all you need to do is given. Now angle additional postulate, over here we know from supplementary theorem, supplement is about 180 degrees. Now all you need to do is add these both and that will be 180 degree. What is these values? Substitute over here by substitution property, x plus 9 plus 2x. The x value is 57 degrees. Now is it over? No, they asked us to find measure of angle 4. We found the x value. Now substitute x over here and solve. You will get x plus 9, that is 57 plus 9. 66 is your final answer, 66 degrees. Now there is one more thing, just remember, if it's two angles, if it's like a straight line, this is supplement. Now if it is right angle, then it is called a complement. Now it's up to you to remember whichever method is easy, but now I'll tell you how you can remember is, Compliment is telling something good, or you have done something right, therefore you tell compliments. So if they tell you complimentary, remember right, because you are told right or something. The right angles are always 90 degrees. So this is one way. Whereas supplement is 180 degrees. Supplement is giving something extra. Now, if you go to gym, some of you might have known, some people who go to gym take supplements. That is something extra. So 90 degrees complement extra to this. Give another 90. That will be 180. This is supplementary. 180 would be supplement. So that's about these problems. Now it's your turn. Pause this video now over here and solve these by yourselves. And they are not difficult, they're easy, they're simple problems. Please do solve it by yourselves. I'll just tell you over here a few of them. This measure of ABCD, I'll just tell you in general how to do. The total measure is given as 120 degrees. So add them both, they equal to 120, and you can solve it. Now say for example, you can use your calculator for this. Okay, I'm just doing it directly. Now we know 2x plus 5x minus 6, that is equal to 120. That is the angle addition postulate. If you press equal to, you will not get the answer because x is variable. You need to press shift and then solve it up. What is the answer? You will get 18 over here. The x value is 18, but what do you want is CBD. So instead of x, put 18, that is the answer, minus 6. And now this is the answer, 84. So this is the thing. Now over here, x was 18. Oh, sorry, we have to find both. I just saw CBD. We know x was 18. 18 times 2 is 36. That's it. This was 54 and this is 36. Now over here it is the same thing. They have given you the sum. Add them all. You can do it in calculator and solve it. Similarly, you can try all of them. Over here, 2 and 3. Can you see over here, 2 and 3? They have told complement. Complement means a right. These both are 90 degree. Whereas one, okay, and they have told this is equal to this. These both are equal, 1 and 4. And they have given you this measure. So if they have told you 2, you can easily find this is 28. So what is the remaining angle? 90 minus 28. It will be 62. So this will be 62. Now, this total is a supplementary, right? Total is a straight line. So you know this 28, this is 62. Now 1 and 4 is equal. So let me write x unknown value, x and x over here. Because if this is x, this is also x. Why? Because they both are same. All you need to do is now alpha and x plus 28, because it is given. Then you need to add to 62, and then you need to again add x. That will be equal to 180 degrees. So now when you press shift and solve, you will get the answer 45. You can see over here. I'm so sorry, the x value is 40. Yeah, that's it. Correct. I thought we had to substitute anything. No. X is 45, and over here we didn't have an equation. We assume this angle to be x. So now angle 1 is 45. Yes. Angle 2 is not as it's given, 28. Angle 3 is 62. And angle 4 again is 45 degrees. So this is how we can solve all these problems. Please do try it by yourselves and solve. They're very, very straightforward. And if you know one angle, say over here m is 105, then this will be 180 minus that. Same way, easily you can find the angles. The third topic is a simple topic where you need to analyze the figure and solve. Over here, you need to find the parallel lines, parallel planes, and the skew lines. Now we will start. They are asking to name all the lines that are skew to BC. Now remember, skew means not parallel and should not touch this line. So over here, if this is BC, this is parallel, 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 all have the same slope, right? But what about this? This is not parallel, this is also not parallel, but sadly they're touching this line, so ignore them. Now the ones which I will draw in the pink color, here, this is a skew line and this is a skew line, this and this. So DEEH and AF and FG. So these are AF, DE, FG, and HE. Those are the skew lines. I'll repeat the skew lines, skew, that is over here, to BC are the ones which are not parallel and will not touch them. So that's it. So that's how we do it. And now the parallel lines to EH. Let us see the parallel lines. They are mentioned EH. This is the one. So parallel lines would mean having the same slope. So this is a parallel line. This is a parallel. This is a parallel. Apparently only three parallel lines. So they are the answers. That is AB, CD, CD, and FG. And lastly, the planes that are parallel to DCH. See, this is a plane, right? Any 3 points must be mentioned in a plane. So this is a plane. Now, this is not parallel. None of them. Only one parallel over here, this one. So you can tell AFG or ABG or any of the 3 points. This is a plane that is parallel to it. So that is the parallel plane. ABG is mentioned. You can also see AFG is the same thing. So look into the options which have been mentioned and then select it. This is one of the most simple topic. That's it. That's how we solve it. Sorry. Okay. So in the next section, we will move on to the next topic. The fourth topic is with regards to the angle relationship theorems. Now, whenever we know there are two parallel lines, there is some relationship happening. Now, you can see this is transversal. Now, if you consider, say, A and B, these are parallel, and this would be the transversal. You need to see which are the interior angles of the parallel lines. Now, only focus on the ones which I have marked. Two parallel lines, which are the angles inside to each other. That would be this and these over here. They are inside or interior. So always remember the inside angles are interior, whereas the ones outside are exterior, external. Okay. Now the next thing is, if they are opposite like this, they're called alternating. In the other side, alternate. If it is same in the same side, they're consecutive. Consecutive is continuous. Same thing over here. Alternate would mean outside and opposite sides. Now there are few things. If you see an interior angle which is alternating or opposite to each other, they will be equal, provided these two lines are parallel. So now if the A and B is parallel, then I can say 2 and 8 are congruent. They are the same. Why? Because they are interior alternate angles. Or if anyone tells you these both are congruent angles, 2 and 8, then you can tell A and B must be parallel because it's the converse of alternate interior angle. So I'll just recall few of the formulas. One is alternate interior. Next one would be alternate exterior, outside angles, exterior. Now then there is corresponding angle. Corresponding, see, imagine this is a pair. And over here, these are the two parallel lines, L and M. Over here, if I'm considering this angle 4, it's down left side. Then here down left side is corresponding. It is similar to that. Same position. These both are congruent as well. And then lastly, we have one thing called consecutive angles. So now consecutive interior. These both are interior and continuous, right? If you add them up, it will be equal to 180 degrees. This is last theorem. We will now apply these theorems over here. If you want more detail of each and every theorem, in detail explanation is given in the lesson explanations, which is already there. You can check it out, or I'll put it in the comments or the description to that particular lesson explanation. Now over here, if you remember those, these theorems, let us see now. 2 and 7. Here we have 2 and over here we have, 8. Sorry, my bad. It's 2 and 8. Look at them. Which are the theorem? Which is the theorem? It is alternate interior. But now they are asking us whether these are parallel or no. Which lines are parallel? Now, if 2 and 8 are congruent or equal, then A and B will be parallel lines. So here A and B are parallel. Why? Because of the converse or alternate interior angles, converse. That's it. Now over here, 3 and 11. 3 is over here, 11. Now the positioning is the same, isn't it? The position. 3 is down right side, 11 is down the right side. It's corresponding. So converse of corresponding angles theorem. 12 and 14, let's see where is 12 and 14. Over here is 12, over here is 14. It is exterior outside angles to AB is parallel now. Now before that, once again, 3 and 11, if you notice, makes L and M parallel. And now over here, 12 and 14 will make A and B parallel by alternate exterior angle converse. Similarly, please do solve these by yourself. See, just the same similar thing, similar concept, but the values are different. Do solve this up. So one by one, pause the video, solve it by yourself, and then check the answers. I'll quickly go through this one, the fourth one. 5 and 12 will make L and M parallel because they are equals to 180. That means it's converse of interior consecutive angles. See, consecutive interior angles converse or converse of consecutive interior angles. Similarly, all they are very, very straightforward. Please do solve them by yourself and then check for the answers. The fifth topic is on rotational symmetry. We need to find the order magnitude of symmetry, and then we need to also identify whether it has point symmetry. What does all this mean? First of all, if you can rotate any object, now rotate this object, and if it is shaping into itself, now say imagine I will take this as A and this one as B. Now let me rotate this. This will come down over here and this all will change its places, okay? And if this is C, C will come down, D will come down, everything changes. So now the base will be B, the A will go to the left side like this, A, and then if you just shape it itself, okay, that's a not that accurate, but I hope you get understand what I'm trying to say over here. So then now if you look carefully, it'll be something like this. This object, whenever you rotate it, it's going to shape into itself. When you rotate it side by one. So this is having a rotational symmetry. That's it. Rotational symmetry means you need to rotate the object and you must get the same object before 360 degrees. Now 360 means an entire turn. No, not 360. Before 360, yes, we got it. How do we understand how many degrees do we have to turn this? It's very simple. First, you need to see the order. How many times can you rotate this to get the same image? In this case, it's the number of sides because each time I change the side, I'm going to get it. That's 1, 2, 3, 4, 5. 5. The order is 5. Let me clear all this. The order would be 5 over here. The rotational symmetry exists. Yes. Order is 5. Now, what about the magnitude? Magnitude is always given by 360 degrees, the total angle, divided by the order, that is over here in this case 5. That you should just solve it in the calculator. So 36 times 2 will be 72. 72 I believe. Yes, 72 degrees. So this is the answer over here. Now how we got it? We have to find the order and divide it by 360, and that's it. You will get the answer for the magnitude. Now, what next other things? They have told about something called point symmetry, right? What is this point symmetry? Point symmetry is basically if you can shape this, you can rotate this object along 180 degree along the point of origin. So now what it means is, imagine I have a rectangle like this, okay? Now, if I do 90-degree rotation, it'll be something like this. No. But if I do again 180 degree, it's going to be the same rectangle. So whenever you can rotate an object along 180 degree along its center, then it is point symmetry along its point. Now, what is the shortcut to find this out? Make this upside down. So make this upside down. This goes up. It'll change like this, and then the pointy part comes down. No, it's not. Okay, that is a very bad drawing.
but I just hope you understand what I'm trying to say. It'll be looking like this, isn't it? The pointing comes down. If you make it upside down, 180-degree means upside down, isn't it? So no, it's not the same. There is no point symmetry. That's it. If it was, say, the letter Z, turn it like this, one turn it'll be N, but again you turn it, it'll be again Z, isn't it? Can you see this Z? If you turn once, this will come this side, it'll be N. Now again, turn this to the other side down, it'll be Z. This has point symmetry. So this is the example. Now let's see one more problem, few more. Over here, this one, as you look at it, you can see one of the shape is so odd over here. It doesn't matter how much you change. See, all are straight, but this is odd. So one time you rotate, this is going to come up. Then it's going to be like this side. There is no way you will get any symmetry. There is no way, because there is all straight lines and this is odd line. No, there is no rotational symmetry at all. If there is no rotational symmetry, there is no order, none, then there is no magnitude as well. There is no point of symmetry also, because if there is point of symmetry, that means it will have a rotational symmetry of 180 degrees, isn't it? So there is none over here. Now this one, this is interesting. Two sides are parallel, these are in relation. So now what if I rotate it 90 degrees? Because there are four sides, the minimum you can rotate is 90 degree when this side comes down. It's going to be like this. Now, do you think this is having a rotational symmetry of 90 degree? No, it's not going to happen. Why? Because this two is not equal, right? And these sides these are a little bigger. I've done a much bigger one, but this for your understanding, this and this is not equal. So no, there is no 90 degree. Let's try again. Let's rotate this again. This will come down and these sides will go up and it'll be like this. Now, yes, you will get the original image. Why? Because 1 and 1, this will be 2 and 2, this is 2 and 2. My drawings are not accurate, but I hope you understand whenever you do this, it will be the same shape. So this has rotational symmetry. The order is 2 because, okay, now 180 degree, yes. Now, one order is done. If you do it again, it's going to be something like this. But again, at 360, you will get one more. So there are two orders, two times it can be shaped when you rotate by 360. So if it's two times, that means the magnitude is 180 degree. If the magnitude is 180 degree, it has point symmetry because it maps about its center, it maps onto itself at 180 degrees. So this is the concept behind the symmetry. It is very simple. It's just that you should know that point symmetry means 180 degree or upside down. Just think about the upside down, the shortcut. If you can see, yes, this upside down, it'll be the same thing. Okay, now one way to do this is if you have a tab or a mobile phone in your hand, just turn it upside down. Just if your mobile phone is like this, so okay, now it's all full screens. So just swap it, turn it upside down. If this is A and B, so make it B and A, upside down B and A, and then see this image will be the same. So just swap it. It will be the same size. Sorry, my drawings are always magnified or changed. So this is the thing. That's a shortcut way to understand the point symmetry. Whereas rotational symmetry is you need to analyze that object, see whether you can map onto itself before 360 degree, and if so, how many times, and then you can easily find it out. So that's the end of that topic. In the next section, we will learn other topics.
The sixth type of topic is to prove triangle angle sum theorem. Now, this triangle angle sum theorem is very simple. All it says is a triangle is made up of total angle of it is 180 degrees. So now if you add the angles of all the triangle, the sum will be 180 degrees. So this is the concept. Now imagine you have been given this to be 60. This is 60 over here. And then what is this angle? All you need to do is 180 minus 60 minus 60. That'll be 60. That will be the answer. And since all the angles are equal and then the sides will be equal, it'll be called as an equilateral angle. Now, over here, you can see closely, this is a square or rectangle, but it's all made up of triangles. This is one triangle over here, one more, one more, one more, right? So all, if you add the angles individually, if you add this triangle's angle, that is ABF, it'll be 180. And if you add AEF, doesn't matter the size, the angle doesn't, doesn't depend on the size. So angle will be 180 itself. But we need to find BCD, that is B, C, and D over here. BCD, this is the angle. How do we do it? All we need to do is find the angle. Okay, now here this is also in terms of x. First, find the x and then substitute and solve. So what I mean is, you need to find the x value first. But before that, this is unknown right over here, which is this angle. If you look closely over here, you have a 90 degree. So if you have a 90 degree on one side, always a straight, this will be a linear pair. That means when you add them, it will be supplementary angles. That means if you add the two angles on a straight line, it will always add up to 180 degrees. So this is 90. So if you do 180 minus 90, it is 90. Or as a thumb rule, you should always remember, when you have 190 degree, the other side will definitely be a 90 degree as well. So now over here, you got this 90, so this will also be 90. And there is one more rule that says, if there is 190 degree on a triangle, then the other two sides must add up to be 90 degree. What I mean is, let's do this with the triangles angle sum theorem. I would be adding the angle B plus angle D plus angle C, right? This total angle will be equal to 180 degrees. So now let me keep B and C as it is. Angle B plus C. But what is angle D? This is 90. So I'll take this to the other side. It'll be 180 minus 90. Now, if you look carefully, what's going to happen? When you add these both, you must get 180 minus 90, which is 90. So we don't do this all the time using triangle angle sum theorem. Uh, all we need to remember is, whenever there is a 90 degree, the other two angles add up to be 90 itself. So now I can directly write, say like this: BCD plus DBC equals 90 degree. And this is all what I just now told over here about the 90 degree and the summing. Now substitute that. BCD is 2x over here. BCD, it should be first, but anyways, it's the sum of these both. So when you sum this, x plus 8 and 2x minus 2, that will give you 90 degrees. Now what else? You need to just simplify this. Now you can simplify this by adding the x's. 2x plus 1x is 3x, and add 8 minus 2, subtract, and then take it to the other side. What happens? 6 will become negative, because 8 minus 2 is 6 over here. When you change the sign or subtract both the sides by 6, so it'll be 90 minus 6, that's 84. I'll write it directly, 84. So then it'll be 3 divided by 3, 2. Okay, it'll be 28. 28 will be the answer for x. So now this is the answer. Now, if you're getting confused with these steps, you can also use your calculator directly, because you have your scientific calculator. You can double check your answer by putting alpha x, this term as it is, alpha x plus 8 plus 2x, that is alpha and this symbol, minus 2. What is that equal to? It is equal to 90. Now, if you press equal to directly, you will not get the answer, because you have pressed the equation. You need to press the shift button and then solve the equation. And now press equal to, your answer is 28. That is absolutely right. You can put the brackets if you're thinking why I've not put, but since it's all plus over here, it doesn't, you're adding those both, it doesn't matter. So if it was minus, then it would be very crucial to put the brackets. Shift and solve will give you the answer. If you're thinking how I got that x, you can rewind, go back in the video, or alpha and this symbol. That's it. Now here we got the x value as 28. But remember, this is not the answer. You need to put this back. Put this back. 2 times x minus 2. Instead of x, you put 28 and then solve it. 28 times 2 is 56. Minus 2 is 54 degrees.
So this is the angle of C. So that's it. So similarly, you can solve the others. Now, please do solve these by yourselves and then check the answer. Pause the video now. Try solving it by yourself. I'll just quickly tell you how to solve it if you're getting confused. You know one angle over here, this is 90, two angles are known. The total sum must be 180 degree. So 180 minus 90 is 90, minus 30 is 60. So angle number 2 is 60 over here. So same way over here, you know this is 90, so this will be also 90 left side. 90 plus 60 is 150. 180 minus 150, this will be 30. So that's how we can do. Similarly over here, this all nothing is right angle, so you need to solve this first. Add these up, it'll be 180. So 180 minus 66 minus 58 will give you 1. Then if you know 1, imagine now 1 is equal to uh, I don't know, I didn't calculate this, but anyways, if say for example it's 40, which is not equal, which is not the correct answer, say 40, then this will be 40. Why? Because of the vertical angle theorem. Always the vertical angles of two straight lines, if there are two opposite angles, they are always equal. You can see one is 56, and this over here 2 will also be 56 because they are vertical angles. And then you can do 180 minus 50 and 56, you'll get this. Similarly, you can try solving the others. They are pretty straightforward. Over here, you can just solve this first, and then you can solve the others one by one. Please do try them by yourself and then check out the answers. Over here, it's the same thing. Over here, it's just that these both are equal. They are mentioned they're equal, and then you can solve it. And if you have any doubts, you can just put it in the comment section, and I will get back to you as soon as possible. Same way, please do try these as well until 7. This is it. Now over here you can see all the angles are given in terms of x. So basically you can easily put this in calculator and solve x, that is 7x minus 7 plus this term plus this term must be equal to 180. You will find the x and then put the x back over here and solve it up. So this is it. This is how we can solve it. And over here you can use the exterior angle theorem, or if you're getting confused, you can just solve this one. Okay, 180 minus 9, and these both are equal. Just put it in the calculator and you can easily solve it up. In the 7th topic, we have plenty of polygons. And here we need to see the corresponding parts of them and then write the congruent statement. What it means is, now imagine I have two triangles. Now, okay, that is a very bad drawing. Let me just draw like this. Okay. If they are congruent, then the sides, all the sides over here will be equal to each other. But now all the three may not be equal. This might be 5, 6, 7, 5, 6, 7. So how we do is, if one line is mentioned and this is mentioned, they both are equal. Another side will be having two lines, and then over here there are three lines. That means this line is equal to this with this, and the bottom with bottom. That's what it means. Similarly for angles, if one angle over here, that's equal, two over here, then it's equal over here, and lastly we have 3. So now if at all this was given as A, B, and C, and this as D, E, and F, we can easily write ABC is congruent to DEF. But this won't be just same like that. See, now here you can see they're tilted. They are in different shapes. They have changed their angles. I mean, they're congruent, but they are in different orientation. That's the right word. Now, what you can do is, one way is leave one of the triangle as it is. Let us leave ABC over there. And this one, let us reconstruct according to ABC. Over here, AC is having one line. So in this triangle, the other one, which I'm now reconstructing, that is BDC, which is having one line, that is B and D. Let me draw it down with one. Okay. Now over here, looking at this, you can easily understand A is equal to D. Why? Because one and one line. So I will put D over here. So naturally, the other side will be B. Okay. Next one. That is done. This long line was two dashes, so this will be two dash. Then we have B over here, but in this case it'll be C, and then the last line is 3 dash. So now we can tell D is having 1 dash, B is having how much? 1 to 3. So it is 1, 2, 3, and this is only 2. And you can compare this. You can see this is 3, this is 2, and this is 1. Absolutely, this is the correct answer. So this is how you can find the congruent statement. This is not over. You can tell A and B, D is equal, B and C is equal, and C and B is equal. So the congruency statement would be A, B, C. You can write anyhow for the first one. The next one, it's triangle ABC congruent to, this is the symbol, triangle which one? A is D, the corresponding part. B is C over here, and lastly we have C as B. So this is the exact correct answer. So that is the thing. ABC is congruent to triangle DCB. Similarly, over here you can make the same way. Now over here, this double dash is over here, so let me just write this, and then the single one is over here. We can easily observe J and K are opposite angles, so that will be same. So if this is J, the corresponding part over here is L. Upside is parallel over here, so it's K, sorry, over here two lines, that is M in this case, and K with the one line, L and K. So this would be the answer. So it's just that getting the drawing correctly. Then it's just writing, see over here, J is corresponding to L, whereas K is corresponding to M, and M is corresponding to K. So this is how would be the congruent statement. Similarly, you can do it for others. Over here, it's much easier because the angles have been mentioned as well, and the sides have been mentioned. You have to just rearrange this. You can get this shape into the other side or this into the first one. However, now if you're getting this, 5 will be at the bottom, that is Z and Y, and then 4.3 line will be drawn like this will be X. That's it. Now you can write the congruent statement. ABC is X, Y, Z. That's it. So please do all these problems by yourself. They are very, very straightforward. There's nothing much in this. It's just polygons over here. Now A is 109, over here 109. B is 108, 108. Similarly, you can do all the others. So A is corresponding to F, AF, B, J, B and J, C and C is 111, C and I. So C and I, yeah. Similarly, you should do the others. Over here now, before we finish this, this is another type of problem where they have asked you to solve for x and y, but they have already told they are congruent. What is congruent to what? A is congruent to F, B is congruent to D, and C is congruent to E. You can see there are two unknowns, x and y. First, let's solve for y. Why? Because this is 1, B and D is already congruent. We know. So y must be equal to 48. That is very, very straightforward. This is 48 degrees. No doubt, because it's very easy to solve it. But what about x? You know two angles over here, 108, 48. Total angle of a triangle is 180. Just subtract 180 minus 108 minus 48. Now, if you solve this, you will get the answer for A. So let us do this quickly. 100 will be 80, 72 remaining. 24, I believe. Okay. So now, once you have got 24 degrees, this is 24. If this is 24, then this can be equated to 24. 24 is equal to 2x minus y because they both are equal. Now we know y, right? Y is 48. So let's take the this to the other side. So it'll be 24 plus 48 equals to y. What is the answer over here? 48, 20, 24, 48, 72. 72 equals to y. Divide both the sides by 2. Y is equal to 72. It will be 36. 36 times 2 is 78. 72. So this is the answer. Let's just check. Yes, x is 32, 36, and 48 is the answer. So this is how we can easily solve it. Whichever method is convenient, you can directly put that in calculator as well. You know y is 48 and this is 20, 24 we got, I guess, 24. So equate 24 is equal to 2x minus 48. You will get the answer directly. So this is how we can easily solve this. Please do try all the problems by yourself. If you do not get the answer, do post them, do comment on the comment section, any of your questions, and I will get back to you very soon. The eighth topic is on the postulates of sides and angles. Now you can see there are three postulates: SSS, SAS, ASA. What does that mean? These means if all the sides are equal, then they are congruent. If triangles. Now say for example, there are two triangles over here. If all the sides are equal to each other, this sides and these sides are equal, then these two triangles are definitely congruent. Whereas over here, if two sides and the included angle, a side, then an angle in between them and another side, if these are equal, then again they are congruent. And lastly, we have angle, side, and angle. If there is an angle, then a side, then an angle, then again they are congruent. So these are the three postulates. Based on this, we have to solve problems now. We need to tell whether these triangles, you can see this is one triangle on the top and then one on the bottom, whether these are congruent to each other. And if so, which is the congruency, which is the postulate that makes it congruent? GHL, KJL. Over here, you can see the two sides are equivalent, are equal. See, this and this is equal, this and this is equal. And what about this angle? They have not given anything, but we know from vertical angle theorem, this angle will be equal. So that is congruent, that is SAS. So we know from SAS congruency postulate that these both triangles are congruent because this angle is vertical angle. What about this one? Over here we have the side equal, this one, and we know this is a common side, right? Whether it is this triangle or this triangle, the measure of this will be same. If this is 5 centimeter, then both the triangles will have 5 centimeter line, this one. But do we know any other angle or any other side? No, sadly, we don't have enough information. So it is no. So you cannot use SAS or SAS. You can't use any of them because there is no enough information because we don't know whether the other angle is angles or other sides are equal. And what about this top one? Over here, we have the side equal and this angle is also told to be equal. Now, from that information, we can easily tell this middle side is also equal. Why? Because this is the same side for both the triangles and it will be S side angle side postulate, SAS postulate makes them congruent. So that is the answer, SAS. We can tell triangle A, B, C and over here A and C, D, A are congruent because of SAS postulate. Now, what about this last one? There is 90-90, this angle, this angle. Now, do we know whether the sides are equal or any other sides is equal? Sadly, we do not know over here any other congruency. It's just the two angles. Even if all the three angles are equal, that doesn't mean it's congruent. They might be similar because over here all three angles are equal because two are known. This will obviously be the same. If all the three angles are equal, that doesn't mean that they are congruent. They will just be similar. We don't have enough information to confirm either by SSS or SAS that it is congruent. So that is it. It is a very basic one. Just remember the three postulates and then you can easily solve these problems. The ninth topic in this end of term 3 exam questions is about AAS congruence criterion. AAS means angle side. We had gone through this in a couple of videos before, I believe, about all the different postulates of congruency. Now this is one of it, where two angles and a side is congruent or equal, then the entire triangles will be congruent. Now, this is a proving problem. I'm not exactly sure how this will come for MCQ. Maybe they will ask you, give you a statement and then ask the reason for the statement or something. But once we study this problems thoroughly, you will understand and you can solve it any way they ask you. So let's look at this first one. They've asked for two column proof. Given AB is parallel to CD. Look at this. AB and CD are parallel. And then CBD. Angle CBD is congruent to ADB. That means this and this is congruent. Okay. We need to prove this triangle ABD is congruent to CDB. They have given these both are equal. How can we do the other steps? Let's see. For this, you can do a column, two columns, say for example, like this, and then write the statements over here, statements, and then reasons. And then write the statement and the reason, and you can solve it. Or you can just write the reasons in the bracket, however it's convenient for you. This is more preferred. All you need to write is over here, AB is parallel. These two lines, straight line means it's parallel to CD, and the reason is given. So same way you need to write all the others. So that's it. So just remember this box, statement, and reason. Now, next one, angle CBD. This is also given. Angle CBD is congruent to ADB, given to us. What about the other thing? Now, since these two are parallel, we must recall, remember we had seen few of the theorems about parallel lines, angle, interior angle, exterior angle, corresponding angles. Now we must recall them. Why? Because there are two parallel lines. If the two lines are parallel, then we can use those theorems and we will use them now. ABD, can you see this angle over here, which I'll mark it as 2? ABD will be congruent to either CDB or BDC, this one. Why? Because they are interior angles, right? They are inside the two parallel lines and they are alternating angles. This will be congruent because they are inside the two parallel lines inside, and because they are mentioned this is parallel over here, only then we can use this theorem, otherwise no. Now because they're inside and they're alternating opposite sides, and this was already given, so we got two angles side to side equal. And now carefully look over here, this line, this is the same line for both. Don't you agree? If this is 5 centimeter, even for this triangle and this triangle. So BD and BD, it's reflexive property because it's the same line. If it's same, it's basically like a reflection. So we call it reflexive property. Now from ASA, that is angle side angle, we have solved angle side angle. We have told that these two triangles are congruent. That is how we solve this basically. Now these are the statements and these are the reasons. So this is how we solve. Remember to write the statements and the reasons. Now maybe they might give you a statement and then ask you the reason. So in the MCQs, right? Because you will have 4 options. So you can easily look into the options, deduce the others. You can easily tell, okay, this is wrong, this is correct, this is wrong, this is correct. So please do check the options properly and then solve it up. Now, another one over here. So they have given few things, that is S, V, and T are the midpoints of SV. Prove the two triangles are congruent. I'm just checking for the question. Okay, I'm sorry. I think so. The figure is missing over here. Anyways, we can do with this itself. Let's just try to assume there is two triangles, and they have told SV is the midpoint. Okay, and the angles are equal. Okay, it's very hard to do it without the figure. We have to prove these. So I will just tell you over here what's there. S and V is congruent over here. Why? Because this is the midpoint. Okay, let me tell a few things of midpoints. If you have angle like this, and I tell this is an angle bisector, if it's given, if it's angle bisected, then these both angles will be equal. Please remember that. It will always be equal. Now about midpoint, if I have a line, say S and T, and S and V, and then I tell T is the midpoint, then these both lines are equal. That is about midpoint and bisector. These are important, crucial things. So even though we don't have the figure, we can at least solve this. And then over here, ST is congruent to TV. Why? Because that's because of the midpoint. Now they have told T is the midpoint of SV, right? That means this is phi and this is phi. Yes, they must be congruent. Congruent means equal. Then we don't have the figure, but from the figure we can tell this is vertical angle theorem, and then we can easily prove them. So it's very simple, just like this, but it's very hard without the figure. That I'm missing it. I apologize for that. But anyways, um, just like what we have followed over here, same way. Let's see the other problems over here. Say, for example, the flow proof. Okay, this is interesting. Now we have two column proof, which we just now saw, and there is something called a flow chart or flow proof. It doesn't matter because over here, basically you need to just see the options, right? So it doesn't matter which way you prove it, you should just basically prove it. In case you get so confused with this flow chart, just do the statement and reason, it's fine, because the same concept, it's just presented in a different way. It's basically the same food, it's just a different platter. That's the only thing, you know. So now what do we do over here is you need to mention all the givens. This is given, right? A B is congruent to CB. That is AB and CB are equal. Okay, that is given. What is another thing? They are also given that A and C is equal. See, A and C. It's only possible with the figure, so that's why we struggled in the last problem. I'm sorry for that. Now, A and C over here are congruent. Okay, that's also given. What about the other thing? They have told DB bisects ABC. ABC is bisected by DB. That means this angle over here and over here are same. Then, what is remaining? We need to find, okay, 1 second, let's see what and all we found out. Angle, side, angle, side, this much was given, and this is the bisector. That means this and this angle are same. That is what we are telling. ABD and CBD are equal. Why do we get this? Because that is the definition of the bisector. A bisector over here means a line. This is the bisector. B means it cuts this angle into two equal parts. If this angle was 60, it will cut into 30 and 30 equally. Okay, that is about angle bisector. Now we have angle, side, and this angle over here. So we can easily tell because of ASA postulate, it is congruent. So this is it. So this is how we can easily solve it up. And okay, now this is one more thing. What they have asked us to prove AD is congruent to DC. Now, if we prove two triangles are congruent, then all the parts are congruent. This CPCTC, what does that mean? It means that congruent parts of congruent triangle are congruent. There is so much congruence. Now, congruent parts, that means congruent parts of congruent triangles are congruent. So, sorry, I'm so sorry. It's corresponding parts. Okay, I told three congruents. I'm sorry, I couldn't stop laughing just now. Its corresponding parts of congruent triangles are congruent. Okay, corresponding means now imagine these two triangles are congruent. You should see the corresponding. Now, if I take this side AD, this is the corresponding side. This is DC. So or CD or DA over here. Anyhow, okay, AD and DC. So if I consider this is the corresponding side. Because these are corresponding triangles, they are always congruent. Okay, lots of information. Just please take your time for these videos because they are all paragraph proofs. Over here, it's again the same. All the proofs is written. Just go through it. They have given a lot of information. Just find which is find angle, side, and angle, and then you can easily solve it up. Over here, they have already mentioned CD bisects AE. So over here, this line is bisecting AE. That means AC and CE are equal. So this is equal. Then find the remaining angle. They have told angle E is equal to BCA. Okay. Then we have parallel lines, and we can easily find these two are congruent because of corresponding angles. You know, that's it. You need to see what is given and then you need to see what can be solved. So that then easily you can prove them congruent. Same way over here. Make sure you read through this. Over here, it's again a simple one because it's 90 degree over here. Then this is equal, and then you should just find one more angle. Sometimes they'll mention the angle, so it is very simple. That's how we solve it. Over here, they have mentioned CE bisects. Okay, when CE bisects, these both are equal. If this is 90 degree, this is also 90 degree, and this is a common side, so this is equal. So angle, side, angle. Very simple and straightforward. Please do solve them by yourself and then refer the answer. Same way, try this by yourselves and then look for the answers over here. All the answers are given. Now we move to the final topic in the part 1, that is the topic number 10. We have to use the right triangle congruency theorems to prove relationships in geometric figures. Before we start the problems, let's quickly go through a few of these things. Leg, leg, hypotenuse angle, leg, angle, hypotenuse, leg. You might be thinking, what is this? If you have not come across this before. Now let's see over here, there is a right angle. There are two right angles. In a right angle triangle, you will always find a 90 degree. Okay. So now I will draw something like this. It's much easier. If this is 90 degree, the opposite side to the right angle is always hypotenuse, h. This always must be remembered. It's always hypotenuse. Now, what about the other corresponding sides? They are generally called legs. Okay, so now this is the leg and this is another leg. It depends. Now, which this will not be the hypotenuse, other two will be the, sorry, this will not be the leg, that is the hypotenuse. Other than hypotenuse is always legs. Now, one will be beside it and one will be other side of it. So now let us look carefully over here. In a right angle triangle, if the two legs of this right angles of the two triangles are congruent or equal, then it is congruent. That is what it says. This is called leg and leg. Why? Because there are two legs, both the legs are congruent. Now similarly, if you have a hypotenuse and an angle, it doesn't matter which angle, this or this. If you have the hypotenuse of a right angle and then the angle, then again it is congruent. Or if you have leg and an angle, but this is important, this is the 90 degree, right? The leg and angle must be like this, same way over here. Then we can say this is also this is also congruent. And lastly, we have hypotenuse and a leg, that is the hypotenuse and any of the leg, that will be congruent as well. So these are the theorems which you must remember, and now they're asking us whether each of these are congruent, and if yes, we should tell which congruency. Let's look at this. We have 90 degree over here, we have a leg, it's equal, they have given. And you can see this is from reflexive property, it's the same line, the hypotenuse is just the same, so it is hypotenuse and leg, or leg and hypotenuse, but it's written as HL. We can see over here HL is the last one which we saw, hypotenuse and the leg. So yes, they are congruent because of hypotenuse and leg congruency. What about this one over here? This also we just now saw there is an angle and the leg over here, angle and leg. So it is leg and angle, LA. Now over here we have 90 degree and then there are two legs. They all are congruent. So it's leg congruency. What about this one over here, the seventh one? We have an angle and we have a leg. Over here, now look at this, the other angle, that is this and this. Is it the same? Okay, they have told this and this is equal. Okay, this is the 90 degree, this is the 90 degree, but this angle is equal to this angle. Now, it is very important, the positioning is same. Did they tell us this side and this side? No, they did not mention that. They have mentioned some other side. So we cannot tell this is congruent, because if it was this side, yes, then 90 degree leg and the angle, 90 degree leg and angle. But over here, it is not like that. Here, the problem is we have another side which is, which is not in between. It's not included. So we cannot be 100% sure that this is congruent. So we can tell it's no enough information, not enough information, sorry. So I hope this is clear, because there are two sides which are equal, but they are not the exact congruent, they're not corresponding sides. That's the thing. They're not corresponding sides. Now let's look at this one. Over here we have a right angle, angle and hypotenuse. Angle and hypotenuse is HA. Yes, that is congruent. We have seen the congruency. And last one over here, we have 90 degree. Okay, that is fine. We have been told this leg and this leg is equal. But is there anything else given? No angle, no leg. So no, not enough information again, because we just know right angle and an angle. So this is how we can easily solve them up. I hope this is clear. Please do try them by yourself, and then you can check for it. So that's the end of the part one. Please stay tuned for the part two, and please do subscribe to my channel if you have found it useful, and do share it among your friends. All the best and happy learning to all.